Railroad transportation has a long and proud history in this country and is a critical element of the American economy. Every day, freight trains carry different types of cargo all over the United States. At the same time, commuter railroads and Amtrak transport many thousands of passengers to work and other destinations. Railroad operations are inherently safe, but when train wrecks do occur, they can have a devastating impact on people, businesses, and the environment. That is why it's so important for emergency responders to plan ahead, to be prepared in case of a train accident. This video is intended to help emergency responders like you, fire departments, police departments, and other rescue personnel to plan now so that you'll be prepared to rescue railroad crew members safely and efficiently during an emergency situation. Advanced planning will also help to minimize the adverse effects of the wreck on the environment and those who live and work along rail lines. This video will help you to understand how the railroad transportation system operates, assess your coverage area for special risks, approach an accident site and enter a locomotive after an accident and extricate the crew, and provide you with special instructions about dealing with accidents that occur on bridges and in tunnels. The first and most important goal for rescuers is always to protect human life. We'll show you how best to protect yourselves as you enter the accident scene, and we'll demonstrate the most effective techniques for extricating train crew members from the site. Protecting the environment and minimizing loss of cargo are two other very important concerns. However, this video focuses only on life safety. Let's take a look at an actual freight train accident that occurred near Clarkston, Michigan in 2001. Two locomotives collided head-on. All crew members of one train were killed upon impact, and that locomotive, which had derailed, caught fire. The second train, also derailed, had landed on its side. Two crew members were inside, both with broken legs. Rescuers tried to enter through the front windshield, but it was too thick and bolted in such a way as to prevent their access. The locomotive's doors were either jammed or too small to accommodate a stretcher, so the rescue team approached a side window, now on top of the toppled locomotive. After removing the window, rescuers assembled a series of pulleys and levers and lowered men in harnesses into the locomotive cab. Once inside, the rescuers were able to put the injured men, each weighing more than 250 pounds, on half-back devices. They attached ropes to these devices and hoisted the injured crew members through the window. These crew members were lucky because the emergency team arrived on the scene with equipment that aided in a successful rescue. However, when asked what additional information would have helped them that day, the rescuers were quick to note that they wished they had known more about railroads and trains prior to the accident. One goal of this video is to provide you with that information so that if you're faced with a situation like this one, you'll be prepared. Before we discuss the train itself, let's look at how a railroad operates. Tracks belonging to every railroad are divided into territories, each of which is under the jurisdiction of a dispatcher, who manages that territory from a dispatching center. The dispatcher is responsible for authorizing and controlling train movement in his or her territory. On single-track lines, it's the dispatcher who arranges for one train to overtake and pass another that's traveling in the same direction, or for two trains traveling in opposite directions to meet and pass one another. Signal systems are automated systems that have been developed to safeguard and expedite train movement. These systems, comprised of lights much like highway traffic signals, inform train engineers when it's safe to proceed on a given track and when they must stop. Areas with tracks that have no signal systems are known as dark territory. In dark territory, verbal communication with the dispatcher is the engineer's only means of determining if it is safe to proceed. The first step in planning ahead is becoming familiar with the terrain of your area. Your department should possess a detailed railroad map that includes railroad mileposts. You should also become familiar with major and secondary access routes, especially those that lead to remote or hard-to-reach spots along the railroad right-of-way. The railroad map, also referred to as a track chart, and other pertinent information can be obtained from local railroad officials. You should know the locations and weight and height limits of railroad bridges and tunnels. These can pose special challenges for a rescue team. Planning ahead also includes identifying all water sources, as well as potential landing spots for emergency helicopters. It's extremely helpful for you to know as much as possible about the railroad and the trains that travel through your area. Get emergency phone numbers from the railroad, and then post those numbers in both your dispatching center and in your vehicles. Learn about the trains that travel through your area so you'll know how many to expect each day. Obtain their schedules if possible, understanding that freight trains do not typically run on fixed schedules. Also, find out what hazardous materials are typically transported through your jurisdiction. It's important to understand the nature of the cargo that's transported, especially if that cargo includes hazardous materials, or hazmat. In the case of hazmat, you'll need to determine whether special cleanup materials should be on hand. If there's no hazmat unit within your department, you should identify the nearest unit with expertise in handling such materials. Post the phone number of that unit along with the others on your emergency phone list. It's also important to plan for worst-case scenarios. Each department should develop a plan and run practice drills that address what could happen in a worst-case situation. These drills can be conducted annually with other emergency operation drills that your community conducts. Practice is especially important if your department has urban areas where people will need to be evacuated, large amounts of hazardous cargo that's carried through your area, trains that travel through tunnels, or trains that cross bridges. It's important for you to know about train speeds and stopping distances. Freight trains carry more weight than passenger trains. It takes a longer time and a greater distance for them to stop. For example, a 100-car freight train traveling at 50 miles per hour can take up to 1 mile to come to a complete stop, up to 2 miles if it's on a grade. In contrast, an automobile traveling at 50 miles per hour can stop within 105 feet. Because it takes so long for a train to stop, you should learn about the speeds and weights of trains in your area, including the weight of the cargo. This information will be particularly important if you must act as a flagger to stop oncoming trains at either end of an accident. The flagger travels a specified distance, depending on the speed of oncoming trains, in each direction from the accident, with at least 3 30-minute highway flares. The flagger lights the first flare immediately after hearing or seeing an oncoming train, and then waves the flare back and forth in front of him at a right angle to the track as a signal for the engineer to stop the train. You may use flags or flashlights instead of flares. However, weather, darkness, and other conditions can hinder the engineer's ability to see signals other than flares, which railroad employees recognize as a universal warning signal. Before approaching a train wreck, it's helpful to understand certain characteristics of locomotives, which weigh between 130 and 175 tons. Both diesel and electric locomotives are constructed of steel, which can be up to 3/8 of an inch thick. The thinnest part of the locomotive skin is the roof, which is 1/8 inch steel. On some passenger trains, the locomotive roof is made of a fiberglass compound. Interior moldings are made of plastic. Freight locomotives have 2 doors, one in the nose and one in the rear. Passenger locomotives usually have 1 door on each side of the locomotive cab and one on each side towards the rear of the locomotive. In some cases, there's another door in the rear or in the front of the locomotive. These doors, especially the one in the nose, are typically quite narrow and do not offer convenient egress in the event of an accident, especially if backboards or other large pieces of rescue equipment are deployed. When the doors are not accessible, side windows provide the best means of entering and exiting the locomotive. The locomotive's side windows, while also fairly thick, are usually single or double sliders that are bolted on. They're relatively easy to remove and wide enough for access and egress, even for backboards. Locomotive windshields are made of 1/2 inch thick laminated glass which is held in place by a clamping plate inside the cab. For these reasons, windshields are not easy to shatter or remove. Freight locomotives usually carry between 5,000 and 6,000 gallons of diesel fuel in tanks located beneath the underframe, residing just above the tracks between the front and rear truck assemblies. Passenger locomotives typically carry between 1,800 and 2,200 gallons of diesel fuel in tanks located inside the locomotive body or in underbody tanks. The diesel engine located behind the cab employs either AC or DC electrical power for traction efforts. There's one red emergency stop button inside the cab, located on the firewall directly behind the engineer's seat, that can shut down the diesel engine. In addition, there are two such red devices located on either side of the locomotive, just above the fuel tank. Pushing in and holding the device for about 10 seconds will cause the diesel engine to shut down within a minute. Electric motors, either AC or DC, are mounted on each axle assembly of the locomotive. Diesel-electric locomotives provide high-voltage electrical power. No one other than a crew member should ever attempt to disconnect an electrical cable or go between or under cars from the exterior of the train until the system has been de-energized. Electric locomotives do not have fuel tanks. They derive all their power from the pantograph on the locomotive roof, which makes contact with the overhead catenary system. The overhead wires are energized at between 12,000 and 25,000 volts AC, and the top of the locomotive is energized as well. Between each car of the train, including the locomotive, there are air hoses that power the train's braking system. If it's necessary to separate cars, these air hoses must be released. A railroad employee should handle this task. If no railroad personnel are available, you'll need to pull up on the lever located at the ends of each car to release the knuckle, and turn the angle cock to the right to turn off the air. You'll then be able to separate the cars. Under no circumstances should you attempt to disconnect an air hose. These hoses are pressurized at up to 140 psi of air pressure, and if unrestricted, can cause serious injury or death. There are several critical steps to take when you're notified of a railroad accident. First, pinpoint the location of the accident using landmarks and railroad milepost markers. Pass this information on immediately to railroad authorities. Obtain as much information as possible from the person reporting the accident and from the involved railroad. Find out how many crew members are on board. There are typically either 2 or 3. Ask if the cargo includes any hazardous materials, and if so, where they are located. Ask for the contents of the train manifest, a document that contains a description of the train's cargo. Send personnel with flares to stand guard on either side of the accident scene and flag oncoming trains. This is especially important if the accident occurred in a dark territory where there are no signals. Depending on the speed of trains in your area, the flaggers may need to go as far as 2 miles out in both directions from the incident site in order to stop the trains effectively. If there are experienced railroad personnel available, they should arrange to stop all train movements before emergency responders enter the railroad right-of-way. Federal law gives trains the right-of-way at highway rail grade crossings over every motor vehicle. This includes emergency vehicles responding to a call. When traveling to an accident, under no circumstances should you ever attempt to beat a train at a crossing. When approaching the site of a railroad accident, remember that your safety and that of other emergency responders is paramount. Before entering the site, your rescue team should use emergency air monitoring equipment to determine air purity and should then follow local air monitoring procedures to avoid exposure to hazmat particles and blood-borne pathogens. Be on the lookout for hazardous conditions, such as surfaces made slippery by ice, water, or diesel fuel. Because the rails could be slippery, always step over and not on them. Remember to always expect a train on any track in any direction at any time. Be on the lookout, especially until flaggers are in position and the railroad is able to contact approaching trains. Stay clear of downed power lines, and watch for sharp edges on damaged cars, equipment, and cargo. Be on the alert for shifting weight especially when moving among the wreckage, and proceed with caution when walking on uneven surfaces. Hot surfaces represent another danger, as they may ignite diesel fumes. The risk of this is high along the roof, where exhaust gases tend to accumulate. There are also other places where fuel leaks are likely to occur. For example, there are vents in the fuel tank through which fuel can leak if the train has toppled over. To suppress the vapors of diesel fuel, a Class II combustible, spread aqueous film-forming foam, often called AFFF or AlcoSeal, over them as a blanket. Note, however, that the foam can make underlying surfaces more slippery. More than one application may be required if the foam blanket is compromised. Before entering the locomotive, ensure that it is stable, especially if it or any of the cars are on an embankment. If its stability is in question, do not enter the locomotive. Because the locomotive is extremely heavy, it's unlikely that it will move after sliding to a stop. However, other cars in the wreckage that could fall on the locomotive could pose a problem. Enter the locomotive only when you're confident that it and surrounding cars are stable. Under no circumstances should you climb onto the roof of a burning locomotive, especially ones with fiberglass tops, which could melt from the heat of the fire. Likewise, never climb on top of an electric locomotive or on top of any railroad equipment under catenary wires without a qualified railroad employee on site. Do not let personnel or aluminum ladders come within 8 feet of any segment of the catenary system, which includes the guy wires attached to buildings or other structures. Consider all wires live unless confirmed dead by a qualified expert. Failure to comply with these precautions is likely to result in serious injury or death. Locate the crew using information from the railroad dispatcher as to how many crew members are on board. Be sure to check the nose of the locomotive cab near the collision posts and near the rear door. If crew members are unaccounted for, check beside the tracks in the event that they jumped from the train. To access trapped or injured crew members, evaluate all the options. Train doors, usually 16 inches to 23 inches wide, may be locked or jammed or too narrow to extricate someone who's hurt. Side windows, which range in height from 18 inches to 28 inches and in width from 16 inches to 36 inches, may be a better option than the doors. Side windows are easier to remove than the locomotive windshield, which is much more difficult to remove than a car or truck windshield. You should consider it as an access point only if doors and other windows are inaccessible. If you rule out all doors and windows for access, the best option for cutting an entry is through the roof, which has a thinner skin than the sides of the locomotive. Keep in mind that the nose of the locomotive is the densest area of all. If you must resort to cutting, be sure to lay down a thick layer of foam and continue to maintain this layer throughout the cutting operation to prevent ignition of fuel vapors. It's important to assess the situation within the cab before entering. Injured crew members may be in the way of the entering rescue team or in the way of the tools or equipment to be used for cutting or extrication. In addition, blood-borne pathogens are always a safety risk. When the locomotive is upright and there's a need for a backboard for transporting the injured, consider a side window for extrication. It may be a better option than a door because it is relatively easy to remove and wide enough to accommodate the backboard. If the locomotive is on its side, you may need to use a ladder or rope to get the rescuers inside the cab. To remove the injured, construct a 4-to-1 mechanical advantage pulley or other system for lifting. If there are railroad bridges or tunnels in your area, it's especially important to include them in your worst-case scenario pre-plans. Keep maps of these sites on hand, along with information on the structures themselves, and run practice drills at these locations. Before approaching an accident on a bridge, you must determine that all train movements on adjacent tracks are stopped. Also determine whether the bridge itself has been compromised. If it's over water, Have the rescue team wear flotation devices and safety lines in the event that emergency responders fall into the water. Check to see if the locomotive or any cars have fallen under the bridge. Be careful when approaching them, especially if they're on an embankment. If the accident has occurred on a bridge with an open deck, exercise special caution because these are more hazardous than bridges with solid decks. An accident in a tunnel poses a tremendous challenge for rescuers. It's important to plan ahead by familiarizing yourself with tunnels in your area and by running practice drills with worst-case scenarios in mind. Hazardous materials constitute a major issue in these cases, especially if any railroad cars are on fire. The location of the accident can also pose problems. For example, a wreck that occurs near the middle of a long tunnel can create a great challenge. Your breathing apparatus may not contain enough air to enable you to reach the accident, and your cell phones and radios may not work in the tunnel. Visibility may represent another difficulty in that it may be extremely limited or non-existent due to smoke and darkness. If the tunnel is in an urban area, police or other emergency personnel may need to evacuate the area. A freight train accident that took place in Baltimore, Maryland in July of 2001 illustrates a real-life worst-case scenario. The train, which was carrying hydrochloric acid among other cargo, entered the 1.5-mile-long tunnel that runs under the city. A car derailed, starting a fire, and soon smoke began to pour through a manhole cover over the tunnel. Crew members were able to separate the locomotives from the cars and escape unharmed. The fire burned on, however, so thousands of people were evacuated from the streets and buildings above the tunnel. Emergency personnel, including hazmat experts, were dispatched immediately. Firefighters, having determined that the derailed train was somewhere toward the middle of the tunnel, donned self-contained breathing apparatus and began to approach the wreck on foot. It was dark and smoky inside the tunnel, and they soon discovered that their air supply would not sustain them if they continued on foot. They therefore entered again, this time in an emergency vehicle, which they backed in for a quick escape in case of an explosion. The fire was brought under control within hours, but it took several days to ensure that it was completely extinguished and that the area was secure. Fortunately, the incident ended with no injury or loss of life. Some of the lessons learned by Baltimore emergency personnel have served as examples to other departments across the country. First, it's critical to familiarize your crew with the entire coverage area, especially with potentially hazardous locations such as bridges and tunnels. Your department should develop a detailed emergency action plan for worst-case scenarios. The Baltimore accident reminds us that, unfortunately, the worst can happen. If your department services an urban area, you should develop an evacuation plan. The Baltimore accident forced a huge evacuation, including thousands of baseball fans from Camden Yards. Your emergency planning should include training sessions for all rescue personnel, with special emphasis on the latest triage methods. You should continually maintain open communication among the various rescue agencies in your area, as well as with the railroads that travel through your area. This includes ensuring that you have current emergency phone numbers on hand and keeping abreast of railroad information about schedules and cargo. People are naturally curious, especially about accidents. Perimeter security is critical, and access to the accident site must be restricted. Maintain an adequate supply of self-contained breathing apparatus and spare air bottles. In an emergency situation, it's essential to have solid leadership and clear accountability so that every member of the rescue team can perform his or her task as quickly and efficiently as possible. Use the incident command system to its best advantage and set up divisions to accommodate all aiding companies. Finally, it's important to provide accurate information to the media so that they will not seek alternative information sources. Several handouts accompany this video. These handouts are designed to aid you in remembering the precautions and steps to take when confronted with a train wreck. The first two handouts are checklists of things to do when approaching the site of the wreck and entering the locomotive. The next handout provides instructions on flagging procedures. This includes diagrams and written instructions on how to properly flag an approaching train to stop. We hope that the information in this video will help your department to plan ahead now so as to be ready to respond immediately in the unfortunate event of a train accident.